Hello everyone, welcome to Vigyan Bharat. We are back again with another interesting video. Today we're going to discuss the problem of the day, which is we are given a matrix 3 by 3 matrix whose columns are denoted by V1, V2 and V3 respectively, and the values are here, and we have to find the sum of all the elements of this matrix a raised to the power 100. So let's begin with noting down the given information. We are given a matrix A whose columns are V1, V2, V3. So I can now directly write my matrix A, which is 0, 1, 0, 1, 0, 1, 0, 0, 1. So this is given to us. Now, because we have to find the sum of all the elements of this matrix, so in order to reach here, we have to compute the matrix product. That is, we have to raise our matrix. We have to multiply our matrix with itself and raise its power. So let's start by computing the square of the given matrix. A square will be same as A times A, and it is 0, 1, 0, 1, 0, 1, 0, 0, 1. So this is our A, and I have to multiply it with itself. So now steps are quite easy, but it is basic calculations are there. So first row, first column will be 1. First row, second column will be, if you multiply here, the A first element corresponding to the first row and second column. So 0 will be 0, 0 and 0. It will be 0. Similarly, first row and third column. So it will be 0. Likewise, second row, first column, 0. Second row, second column, 1. Second row, third column, 0. Third row, first column, and it is 1. Second row, third row, second column, and it is 1. Third row, third column, finally we are left with 1. So while computing the matrix multiplication, here is simple, I would say, an observation. Here I have computed each and every element. Besides, when we go further, you see that because there are more zeros are there now, so we will be evaluating the coefficient corresponding to the non-zero entries only. You will understand what I am trying to say. Now let's go ahead with A3, or we can simply compute directly A4 also from here straightforward, because A4 will be A square times A square. In general, when our given matrix A square, then A raised to the power m plus n is same as A times m, A times n, where these m and n are positive integers. Positive integers. So this holds in general. So easily using this property, I can directly write my A4 as A square times A square. Now A square from the last step is here given by this. So let me note down it quickly. 1, 0, 1, 0, 1, 1, 0, 0, 1. Again one more time. 1, 0, 1, 0, 1, 1 and 0, 0, 1. Cool. Now again we can calculate simply, because here if you observe in the first row, only this is the non-zero element, but what I was saying. So we have to just look for the element corresponding to this element. Here it is 1, so it is directly 1. We don't have to go and check for the remaining entries because they are going to be 0 only. Now here it's first row and second column. So in my first row only this is a non-zero element. So in my second column I have to only check whether the element corresponding to this is 0 or non-zero. If it's non-zero, then I'm going to write directly the answer. If it's 0, then the resulting answer will be 0 itself. And in our case, since first row and second column, so first row, the first element is 1 and corresponding the first element of the second row is 0, so the resulting product is 0. Similarly, first row, third column, corresponding this one here, it is a 0, so definitely the product will be going to 0. Similarly, second row, second row and first column. So in second row only the second entry is non-zero. So corresponding to the first column, I have to only check whether my second entry is 0 or not 0. So since it is 0, so the answer will be 0. So likewise, you can compute it easily now. Now second row, second column, here it is 1. Second row, third column 0. Third row, first column, it will be 2. Third row, it was third row, first column. Third row, second column, it will going to be 2. Third row, third column, it will going to be 1. Okay. So we have computed we raised a matrix first up to square and then here to its fourth power. So if we now make some observations, if we try to see something from here, then going ahead in the calculations will be quite easy for us. You see, there are some similarities in this matrix and this matrix. If I create a block here, see this block only, this block I am trying to say, and see this block again here. So this is nothing but my 2 cross 2 identity matrix. This is my I2, likewise here also. And this column is same, and it is same, but what I have observed that my first 2 by 2 block is the identity matrix. So let's move ahead and compute another power. Let's raise it to power 8, and then let's check whether if there is some pattern which we can find here. A8 will be A4 times A4. A4 was 1001, 22001, likewise 1001, 001 and 22. Let's compute the matrix products again. First entry is non-zero, so here is also non-zero, it's still going to 1. First row and second column, it's 0. First row, third column, again 0. Second row, this is second row, first column 0. Second row, second column 1. Second row, third column is 0. Third row, first column. Now careful here while calculating your calculations. 2 plus 2, that is 4, and here 2 plus 2, that is 4, and finally it will be 1. Okay, so in this case also, if you see here what I was explaining in the previous 2 cases, that here again what I have found again an identity matrix of order 2. So this is a good observation for us that in all the 3 cases we are always having a block which is of course the identity block of order 2. So I think if you have now observed some pattern here. If my power was 4, the elements corresponding to here was 2 and 2, just half of the this power. Similarly, if my power was 8, the elements are 4, that is half of, again, this 4 can be expressed as 8 by 2, what I'm trying to explain, half. So now this column is also same in all the cases. This third column remains the same. So in a similar fashion, in a similar way, we can directly now from here say that what will be my a to the power 100. Now I ask you to pause the video here, just go through what we have come up in our previous cases, and directly using those observations, try to find 100. I hope you have got the observation right, and so that's why this block will again going to be the identity matrix. Here it will be going to half, so certainly it will be going to be 50, 50, and this column was same. So now almost we have completed the solution, because we are now come up with our 100, and now we have to find the sum of all the elements. So it is pretty easy. Now calculate the sum. So the sum will be 1 plus 0 plus 0 plus 0 plus 1 plus 0 plus 50 plus 50 plus 1. Basically, take all the non-zero elements. So in the first row we have 1, in the second row we have 1, so 1 plus 1, that is 2, 50 plus 50 is 100, 100 plus 1. So the answer is 103. I hope you got a clarity how we moved ahead with these observations, and it was a very simple problem. Make sure that we are able to find that observation. Try some other way also, if you can go and find to find the possible sum. There are other ways also which you can proceed for the problem, but since this problem was asked, let me mention from where it is asked. It was asked in IIT JAM 2022 MS, that is Mathematical Statistics. Mathematical Statistics paper. Statistics paper. So there, and it was, I guess, problem 16, question number 16, you can go and check. So in competitive examinations, we are not have that much time. So in those particular scenarios, we have to go through the process which we have just calculated in this problem. But for sure, there is another approach, and you have to drop a comment in the comment box and try to quote the observation or quote the method through which you can calculate the sum of these raised to the power 100, the sum of the elements of this matrix. Before concluding this video, there is some important information that we upload a problem every day on our Telegram channel, as well as across our different platforms on Facebook, on Insta, wherever we are. So you should join them, and at least join the Telegram group, and find its link in the description. And there is also some good discussions going on in that group. So thank you so much for watching, and we'll meet again in a similar video. Thank you so much.